Hi there, and welcome to this lesson on Further Pure Mathematics 2. And in this lesson, we're on Chapter 8, 8.1, and an introduction to polar coordinates and polar equations. But before that, we'll just consider coordinate systems in general. On a two-dimensional surface, and that could be the flat two-dimensional surface of a piece of paper, or the curved two-dimensional surface of something like a sphere, two independent measurements are required to define the position of any point on that surface. So for example, Cartesian geometry uses the two mutually perpendicular measurements, the distances in the x and the y directions. Locations on the curved two-dimensional surface of the Earth are usually defined using the two measurements of longitude and latitude, measurements in the east-west and the north-south directions. Well, in the same way, polar coordinates use two measurements. And the first of those is the distance of the point we're interested in from a fixed point called the pole. So if we have the point P, we're saying how far is it away from this fixed point, the pole. And the distance is normally given by the letter R. The other measurement is the angle measured anti-clockwise from a fixed line, which is called the initial line. So for example, the initial line could be here, and then what we want is the angle going anti-clockwise from the initial line until we meet the line joining the pole to our point. So this angle theta. It's usually measured in radians, and a bit like with complex numbers, it's usually taken to be between minus pi and plus pi radians. So plus pi if you're measuring anti-clockwise above the initial line, and minus if you are measuring clockwise underneath the initial line. The usual convention is to use the origin as the pole and to use the x-axis as the initial line. And it does make things look a lot simpler if you do that. And I think nearly all questions that you will meet will probably do that. And having done that, it then gives us two ways of writing the coordinates of any point P on a flat two-dimensional surface. So in Cartesian form, P will be given by xy, the distances in the x and the y direction. In polar form, P will be given by the coordinates r theta. So we write the distance first and we write the angle second. If we want to convert, first of all, from polar to Cartesian coordinates, we use trigonometry. So you create a right-angled triangle, that distance is x, that's y, the distance is r, and the angle is theta. And the x-coordinate just equals r cos theta, and the y-coordinate equals r sine theta. If we're converting back the other way, from Cartesian to polar form, then we use Pythagoras to find r, the square root of x squared plus y squared, and trigonometry to find theta, the inverse tangent of y divided by x. Okay, first of all, we'll have a look at some questions converting from polar form, from Cartesian form rather, to polar form. Now, when we're converting to polar form, it is a good idea to draw a sketch. It does help with finding the value of theta. Otherwise, it's quite easy to get confused and make a mistake on theta. Anyway, I'll let you have a go at these questions yourself first. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look at these. So the first one, 4-3, doesn't really have any tricks or catches. We'll do a sketch anyway. 3 in the y direction, 4 in the x direction. R will equal the square root of 4 squared plus 3 squared, which is 5. Theta is the inverse tangent of 3 divided by 4, which is 0.644 radians. So the polar coordinates of the point are 5, 0.644. Now the second question has a minus in it, and it's when you get minuses that it really is helpful to draw a sketch. So 12 minus 5 would be 12 in the x direction, minus 5 in the y direction. Finding r isn't a problem. It's the square root of 12 squared plus 5 squared, or you could do 12 squared plus minus 5 squared. Either way, you'll get 13 for the answer. Now this angle theta in the triangle will equal the inverse tangent of 5 divided by 12. So that angle theta is 0.395. But this is the point where we need to be a little bit careful. When we're writing the coordinates in polar form, if theta is underneath the initial line, if we're going clockwise from the initial line, then we have to use minus. So the polar coordinates will be 13 minus 0.395. Third question's got two minuses in it. So the point will be here, minus root 3 in the x direction and minus 1 in the y direction. Again, there's no problem with r. It's the square root of root 3 squared plus 1 squared, which is root 4, which equals 2. And theta, the angle here in this triangle, will be the inverse tangent of 1 divided by root 3. So this angle here will equal pi by 6 radians. But that's not the angle that we want. We want the angle from the initial line. So the whole of this angle here, coming clockwise from the initial line round to there, will be pi take away pi by 6, which is 5 pi by 6 radians. And because it's underneath the axis, it'll be minus 5 pi by 6 when we write the coordinates of the point. Now, moving in the opposite direction. So if we're moving from polar form to Cartesian form, there really aren't any problems. And it's not really necessary to draw a sketch of any sort. The two formulas that we have, x equals r cos theta and y equals r sine theta, they give the correct size and the correct sign for x and y for all values of theta. So things can't really go wrong. Okay, bearing that in mind, have a go at doing these two questions. Okay, let's have a look at the first one. All we have to do is substitute those values into the formulae, which give us x is 4 cos 2 pi by 3, y equals 4 sine 2 pi by 3, which means x is this, y is this, which simplifies to x equals minus 2, y equals 2 root 3. So the coordinates of the point are that, minus 2, 2 root 3. And even if you've got a minus, it doesn't matter. We just substitute those values into the formulae, and we'll get 3 cos minus 3 pi by 4 and 3 sine minus 3 pi by 4. And that gives us 3 times minus root 2 over 2 and 3 times minus root 2 over 2. So in both cases, we get minus 3 root 2 over 2 for the coordinates x and y. Now we'll think about equations. So how you write polar equations of curves. First of all, Cartesian equations of curves. They're usually given in the form y equals some function of x. So y, the dependent variable, is equal to some function of the independent variable. In the same way, polar equations of curves are usually given in the form r is equal to some function of theta. It's not absolutely essential, but that is the normal thing to do, where it's possible. To convert between Cartesian form and polar form, we make use of the 4 equations that we were looking at just now. Now, which ones of those equations that you use will vary from question to question. So example 1, find the polar form of the following Cartesian equation, x squared plus y squared equals 9. Normally you'd be wanting to write r as a function of theta. In this case, it's possible to write r as a constant. Anyway, I'll let you have a go at finishing this question. So pause the video, have a go, and then come back when you're ready. Okay, this is a special case, this one really. It doesn't take too long. So x squared plus y squared equals 9. If I square root that, I'll get the square root of x squared plus y squared is equal to 3. But the square root of x plus y squared is equal to r, so I can just substitute in for r, and that gives me the polar equation, r equals 3. Now, we don't need to worry about the square root possibly being minus in this instance, because r is a distance, which means it's a scalar quantity, and it has to be positive. It's also worth noting that x squared plus y squared equals 9 is the Cartesian equation of a circle, which has got centre the origin and radius 3, which means that r equals 3 is the same thing, a circle centre the origin, radius 3. And that in general, if we have the polar equation, r equals a, r equals any constant, what we've got is the polar equation of a circle, centre O with radius a. Okay, question number 2, example 1, part 2. Find the polar form of the Cartesian equation y squared equals 5x. Okay, I'll let you have a go at that. Pause the video, see if you can work your way through it, and then come back when you're ready. Okay, now with this type of question, converting from polar to Cartesian form, normally the thing to do is just to substitute in for x and y using these two equations. So y squared becomes r squared sine squared theta, and 5x becomes 5r cos theta. If I divide through by r, I'll get r sine squared theta equals 5 cos theta. And then dividing by the sine squared theta gives me r equals 5 times by cos theta divided by sine squared theta. And the simplest way to write that answer is probably r equals 5 cot theta cosec theta. Example 3, or example 1, part 3. Find the polar form of the Cartesian equation y equals minus the square root of 3x plus 7. Okay, again, I'll let you have a go. Pause the video, have a go, and come back when you're ready. Okay, same thing as last time. We'll just substitute in for y and x using these two equations. And that gives us r sine theta is equal to minus root 3 r cos theta plus 7. That gives us r sine theta plus root 3 r cos theta equals 7, moving that across. Factorizing that, taking out the r, gives us r into sine theta plus root 3 cos theta equals 7. And straight away, we can get a version of the polar form. So we have got r here, and we have got a function of theta here, 7 over sine theta plus root 3 cos theta. It is possible to tidy this answer up, this function of theta. But the tidying of this up actually takes an awful lot more work than the question itself. Nevertheless, we'll have a look at it. So it can be simplified by converting the denominator here, sine theta plus 3 cos theta, into harmonic form, so that we just have one trig function. If you remember harmonic form, a sine theta plus b cos theta can be written in the form r sine theta plus alpha. So if we have 1 sine theta plus root 3 cos theta, which is what we have on the denominator, we'll want to writing it in this form, so that we just have one trig function, r sine theta plus alpha. And using the addition formulae, that would be the same as r sine theta cos alpha plus r plus cos theta sine alpha. And then if we collect these terms together here, that gives us r cos alpha times by sine theta plus r sine alpha times by cos theta. So we've got sine theta here and here, we've got cos theta here and here. The coefficients must be the same as each other. So if you remember using harmonic form, that gives us r cos alpha equals 1 and r sine alpha equals root 3. So that's where we've got to so far. If we square them and add them, that gives us r squared into cos squared alpha plus r squared sine squared alpha is 1 plus 3. Factorizing gives us that. And then cos squared alpha plus sine squared alpha equals 1, which is what always happens with harmonic form. And that simplifies to r equals 2. And then to find alpha, we divide one of these equations by the other. So r sine alpha divided by r cos alpha is root 3 over 1, which means that tan alpha is equal to root 3. And that gives us alpha is equal to pi by 3 radians. Which means that the denominator we had on our fraction, sine theta plus 3 cos theta, can be simplified to 2 sine theta plus pi by 3. And that gives us the answer, r is equal to 7 divided by 2 sine theta plus pi by 3. That could be simplified even more. So dividing by sine means we've got the same thing as cosec. So r equals 7 over 2 times cosec theta plus pi by 3 is, I think, the simplest version of the answer. Okay, example 2. Find the Cartesian form of the polar equation 5r equals 2. I'll let you have a go at this yourself. So see if you can make progress with this. These questions are often a little bit different from each other, and the method that works for one question doesn't work so well for another one, but have a go. Pause the video and come back to me when you're ready. Okay, 5r equals 2. That means r equals 2/5. That means r squared is equal to 2/5 squared. Well, r squared is x squared plus y squared. So the easiest way to deal with this is just then to substitute in for r squared. And that gives us x squared plus y squared equals 2/5 squared. And that is a circle, which has got center the origin and radius 2/5. And as we met before, r equals a is a circle, center O with radius a, which is what this equation simplified to. Okay, question 2. Again, we're converting to Cartesian form, and we've got the polar equation r equals 3 minus cos 2 theta. Now that 2 theta is a problem. We are wanting to, well, no, I'll let you try and work out what we need to do. So see if you can move forward yourself, pause the video, and then come back to me when you're ready. Okay, let's have a look. So the first thing is we really do want to have theta, not 2 theta, because all of these equations work around cos theta or sine theta. They don't work around 2 theta. So using the double angle formula for 2 theta, cos 2 theta is 2 cos squared theta minus 1. So this equation becomes r equals 3 minus 2 cos squared theta minus 1, which becomes 4 minus 2 cos squared theta. Now this next step, it is not intuitively obvious, but the easiest thing to do at this point is to multiply by r squared. The reason for that will only really become clear after we've done it. But if we multiply by r squared, we've got r cubed here on the left-hand side, 4r squared there, and then minus 2r squared cos squared theta. Why have we done that? Well, r or any power of r is fine, because we know that r is equal to the square root of x squared plus y squared. So if we ever see r or a power of r, we can just substitute in using this. So the first term is fine, the second term is fine. The next question really is how are we going to deal with all of this? Well, the other thing we know is that r cos theta is equal to x, or r sine theta is equal to y. And this is now very nearly in that form. So what we have there is r cubed equals 4r squared minus 2 into r cos theta squared. And at this point, we can now substitute in for all three things. So r cubed will be the square root of x squared plus y squared cubed. 4r squared will be the square root of x squared plus y squared squared. And here we've got 2 times by x squared, because x equals r cos theta. Now that is the Cartesian equation. The only real question is how much can we simplify it? And I think that's as simple as it goes. X squared plus y squared to the power of 3 over 2 is equal to 4y squared plus 2x squared. Okay, question 3. Find the Cartesian form of the polar equation r equals 8 tan theta sec theta. Again, I'll let you have a go at doing this yourself. So have a go, pause the video, and then come back to me when you're ready. Let's have a look. Now, theta equals arc tan y divided by over x. That's one of the equations. That means that tan theta is equal to y over x, if I just take the tangent of both sides. So the tan theta here, I can just change into y over x. And that gives me r equals 8 times by y over x times 1 over cos theta. Now, if I bring the cos theta over here, then I'll get r cos theta equals 8y over x. R cos theta, again, I know what that equals x. So I can substitute in for that and get x equals 8y over x. As is often the case with this type of question, it can be pretty difficult to work that out yourself, because it's just not clear at the beginning of a question what you need to do. So you do have to be sort of willing just to try things and experiment things. Once you've got the answer, it's pretty obvious why it's the answer. But as I say, it can be quite tricky to work out what the best approach is. This can now easily be simplified to 8y equals x squared, which you could write as y equals 1/8 x squared. Okay, I think this is the last question. Find the Cartesian form of the polar equation r equals 2a cos theta. I'll let you have a go at this, pause the video, come back when you're ready. Okay, let's have a look. Well, 2a cos theta, what I've done here is I've substituted in for cos theta. Using this equation, cos theta is equal to x over r. So r equals 2a times by x over r. I'm trying to get an equation which just has x's and y's in it. The square root of x squared plus y squared, that is what r equals 2a times by x over the square root of x squared plus y squared. It's always the case that once you've just got r's, you can just use this to substitute in for r, and that will give you a Cartesian equation. So at this point, we have got a Cartesian equation. All we need to do is tidy it up a little bit. Bringing this square root across here will give us x squared plus y squared is equal to 2ax. Or x squared minus 2ax plus y squared equals 0, which becomes x squared minus a squared plus y squared equals a squared. And the reason for writing it in that form is then we have a circle, which has got center on the x-axis at a0 with radius a. So in general, if you have the polar equation r equals 2a cos theta, that is what it is. It's a circle, center on the x-axis at the coordinates a0 with radius a. Okay, that does get us to the end of this lesson. If you've got the textbook, then turn to page 153 and have a go at exercise 8a. Thanks very much for listening, and cheerio.